quiz 3. Draw the mechanism and resonance arrows to form two different carbocation intermediates. Draw mechanism arrows to show product formations for both A and B from the intermediates, and then label the kinetic and thermodynamic products. So this has quite a few things. This has just real basic SN1. These are all SN1 reactions. So the first step, the pi bonds nucleophile. React with H+, that's the most reactive thing in the system. React with H+, make a carbocation. It's a secondary carbocation, which then can rearrange to be a tertiary benzylic, or a secondary benzylic carbocation, which is more stable because it can do pi bond resonance. So there's plus charge there. So the solvent adds, we deprotonate, and that gets us to A. Another thing that could happen for a secondary benzylic is we could do a resonance form where we make a secondary allylic carbocation, which then solvent can add. We can deprotonate, and that gets us to B. Good. So now we need to think about which one's the kinetic and which one's the thermodynamic product. So we need to remember what those two terms mean. So kinetic, it means it comes from the most stable intermediate, the lowest activation energy. Thermodynamic means it is the most stable product. So if I just look at A and B, A is more stable than B because A is aromatic. There's an aromatic ring there. B doesn't have an aromatic ring. So this is a thermodynamic product. A is also the kinetic product because to do this resonance right here, we actually, again, break up aromaticity. So this is going to take a lot of energy to do that. So this product is not likely, this intermediate is not likely to form. So A is both the kinetic and the thermodynamic product here. So for this one, again, draw the product and the mechanism for the reactions below. So you are given that you have formed two amines. So hopefully you can recognize that those are coming from there. Right? This is an excess, and the H+ is an excess as well. So this is a urea. So it's going to react. Carbon nucleophile, 1, 2, 3 carbons. Make sure you have the right number of carbons. Adds in, eliminates, kicks out the N-, which just floats around till the very end. Another Grignard comes in. It adds in, elimination, kicks out another N-, which just floats around until the end. Now you have a ketone, which is actually the most reactive of the carbonyls, right? If we go back to thinking about the reactivity of the Mount carbonyl stuff. Grignard adds in again, right? Now we have no good leaving groups. So now everything gets protonated 3 times, and that gets us to this tertiary alcohol with 3 ethyl pieces all added to it at the end. Step 1, step 2. So asking, why does it react 3 times? So if you look at this is probably the least reactive of these things. But I'm telling you it's going to react. So this reacts, and then we make an amide. Well, there's an amide. That's still not very reactive, but it's going to keep reacting because you had to lose those. And then you finally get to a ketone. And now this is actually the most reactive. So that's why it's going to react a 3rd time, because this intermediate is actually the most reactive thing. And again, starting to think about the electrophilicity, how delta plus the carbons of the carbonyl groups are is really important here to think about where they lay along this continuum.